Hello, this is a demonstration of the functionality I've added to Gunship during the first week of my independent study. What we can see here on the right are a number of sample cubes being created and destroyed every frame. This is here to test the component destruction functionality, specifically deferred component destruction. We're testing that I can mark multiple components across multiple component managers for destruction, and they won't be destroyed until the end of a frame. If we close this down and take a look at the code that's running this, you'll find under the Spectacle project, under source files, under systems, level manager system.cpp has the sample code for this. In here, we'll see that in this update, that's getting called level manager system update gets called every frame. And what we do is we ensure that we have 20 entities and we push them onto this queue called entities. What we do is we create an entity. From the transform manager, we assign a transform to it and then give that transform a random position. Then from the mesh manager, we assign the cube mesh to the entity, and then we push the entity onto the queue. And then every frame we pop off 10 entities, and then we ask the transform manager to destroy the transform associated with it, and we ask the mesh manager to destroy the mesh associated with that entity. So what we're doing for all the frames except the first one is we are creating 10 transform components and 10 mesh components. And then the next frame, we are destroying those 10 transform components and 10 mesh components. What this tests is that components can stay alive for at least one frame before being destroyed. In the majority of cases, components will be alive for much longer than that, but this is a minimalistic test. This also tests that we can mark multiple components for destruction in a single frame, and it doesn't cause any problems or corruption. I'm running these tests across the transform component and the mesh component, which are two of the most basic and fundamental components in Gunship. They demonstrate the simple struct component manager's functionality. If we open the demo back up again, over here on the left, we have a second part of the demo. This is testing the alarm functionality. This row of cubes on the left is our reference row. At the beginning, I create 20 cubes, and then they're set with alarms that go off in 1 second intervals. When the alarm goes off, the cube is destroyed, and once all the cubes are destroyed, the row is reset and it starts over. The cubes in this reference row must be destroyed in exactly 1 second intervals, otherwise I know that the alarm manager isn't working correctly. And they must be reset at the end, and that's a persistent alarm loop. These other rows are created initially in the same way as the reference row. 20 cubes are created with alarms scheduled to go off in 1 second intervals. However, at random, several of the alarms in the row are canceled, which leaves behind some cubes that don't get destroyed. This is to test that I can cancel alarms within the alarm manager without having it affect the other alarms that are scheduled. And we can see that by the fact that the cubes that do get destroyed stay in sync with the reference row, because they're always set to happen at the same time as what's going on in the reference row. And we can also tell that it's working because despite multiple alarms having been canceled, the cubes in the reference row still disappear at 1 second intervals. If we close this down, we can go to the Spectacle project. Under source files, we have spectacle.cpp. If we close down this, we can see the initialize scene function in spectacle.cpp is what does the initial scene setup when you start running the demo. The first thing it does is it registers the level manager system, which is what's ticking every frame, creating and destroying those the transform mesh components. It creates the camera, which allows rendering to happen. It also creates the player, which, if we just quickly run the demo one more time, you'll see that there's this one cube at the very center of the demo. That's the quote-unquote player. That doesn't do anything for now. It just shows that I can have a persistent cube that's not changed or affected by anything. And then the initialize scene function also starts the timers for the rows of blocks. Next, let's take a look at the functionality within Gunship itself that I added during this last week. If we go to the lib Gunship project, under header files, under components, there's simple struct component manager.h. So the simple struct component manager is effectively the default component manager for Gunship, at least as far as gameplay components. An example of a simple struct component is under spectacle. If you look under the header files, under components, if we look at bullet.h, we'll see that this is an example of what a gameplay component might commonly look like in Gunship. You'll see that you define a struct bullet that inherits from the simple struct component class. Inside this component, you define whatever kind of data you need to associate with an entity in the scene. In this case, if we have a bullet entity, we only need to associate with it a velocity that allows us to move the bullet in a consistent direction and speed every frame. So with simple struct component manager, this allows us to easily create new component managers, like for stuff like the bullet, or if we need the player to have something, or as the example we discussed earlier with the frigate, it'd be really easy for us to create a frigate component simply by defining a struct and then putting whatever information in it we need, like the health or the move speed or what kind of guns it has. And then we don't need to create a new custom component manager for this. We can simply inherit from simple struct component manager templated to our simple struct component. Inside simple struct component manager, the functionality that I added this week goes to the destroy method, the destroy all marked method, and the destroy immediate method. Destroy allows you to mark the component associated with a given entity for destruction. However, as we'll see in here, it doesn't actually destroy the component. It only adds it to a list of components that have been marked for destruction. Every frame, the scene that's running the update loop iterates over all of the component managers, and it calls destroy all marked on them. Destroy all marked is defined in the component manager base class. If we go up to component manager and then one more level up to component manager base, and this is in the component manager.h file, we'll see that it defines a single method, destroy all marked, and this is required so that the scene manager can perform the component destruction sweep at the end of every frame. Inside simple struct component manager, destroy immediate performs the functionality of actually destroying a single component associated with a single entity. And if you look at this, the way that we're storing our components within simple struct component manager is simply as a vector of the component type. So to destroy components, if we were to simply just destroy the component at whatever it's simply remove that component from at whatever index it is, I'd have to pay the penalty of shifting all the other elements in the array over. To reduce this cost, I actually handle destroying components by finding the index of the component and then swapping the component with the last component in the vector, and then I pop the component off the back, and that has the effect of removing the marked component without having to shift all the elements in the array. This makes destroying components more efficient. However, it has the downside that pointers and references to components don't stay consistent. If you have a reference to a component one frame, at the end of that frame, when the marked components are destroyed, that component might get moved to someplace else in the array, and suddenly the pointer you have is no longer valid. That means that every time you want to access a component, you have to call this get method to retrieve the component again. That would be costly if we had to do a linear lookup by iterating over the entire vector of components and finding the right one. To reduce that cost, I keep a map between the entity ID and the index of the components in the array. So when you call get to retrieve a component, it can retrieve the index in constant time, and then simply return the component. This allows for constant time retrieval of components. So if you were to say have a system that updates every frame and needed to say retrieve the transform component associated with every frigate to allow the frigates to move around, it would be much quicker than it would be otherwise. Now the simple struct component manager is the default component manager in many cases. However, there are types of components that don't work with this. That don't work with this. That require some more specific handling. The alarm is an example of this, because for the alarm, I maintain it as a virtual timeline where the alarms are stored in order of when they're going to when they're scheduled, and I only have to tick the most recent or the soonest scheduled alarm every frame, which saves me processing time for the alarms that are registered. This functionality is more advanced than what's supported by Simple Struct Component Manager, because Simple Struct Component Manager doesn't allow me to sort the components or do anything else like that. So Alarm Manager, instead of inheriting from Simple Struct Component Manager, it inherits directly from Component Manager, and that allows me to do completely custom handling. So you see here, we've got some similar stuff on it, but we've also got, it's completely different from what the Simple Struct Component Manager contains. A lot of the internal component managers for Gunship, so for example, when I start doing the collision in the second half of this quarter, the collision manager is going to have to be a custom component manager similar to this. And if I want to do any other sort of thing, like perhaps if I want a manager for sound components, I might have to do something special with the way that those are handled to allow efficient processing of sounds every frame. So while Simple Struct Component Manager is going to be a commonly used one for gameplay code, these custom component managers are going to be common with internal systems and perhaps any other gameplay systems that have specific cases that need to be handled more efficiently. So part of what I did this week was I wrote the entire alarm manager from scratch. I didn't have any of the alarm functionality working beforehand, and I also the alarm manager is working with you can both assign a new alarm to a component manager or to an entity, and you can cancel a pending alarm. The way the alarm manager works is you pass in an entity that you want to associate the alarm with, you pass in the duration of the alarm, so how long until that alarm goes off, and then you pass in a callback. This callback of type alarm callback has a signature void, returns void, and it takes a reference to the scene, and it takes in the entity that it was originally associated with. This allows static or global functions to be passed in. They don't need to be necessarily associated with the entity that created it, because the entity itself gets passed back into the callback. And this allows for more efficient processing. I don't have to handle things like pointer to member functions or virtual functions or anything like that. So that's it. That's all my functionality for this, everything I've done this week. As far as I can tell, I'm on track with everything I need to do. I got everything completed that I was supposed to for this week, and I'm in a good position to start next week on actual entity destruction. If you noticed in the demo in the level manager, the one that constantly creates and destroys components, it creates a bunch of entities every frame, but it doesn't destroy the entities, and I actually have to manually destroy the components for destruction. Next week, what I'll be working on is, instead of having to manually destroy the transform and the mesh component, I should be able to just destroy the entity, and that'll automatically handle destroying the mesh and the transform for me, which should simplify game code a good bit. All right, that's it. Thank you for watching.